In this paper, we explore how people interact with data within text and voice-based chatbots. Conversational interfaces such as smart assistants and chatbots have become prevalent for a variety of tasks. Natural language interfaces also support expressive ways for users to explore their data. While general design principles exist for chatbot interfaces, little work explores analytical chatbots that support conversing with data. In this work, our goal is to explore how platform and modality differences such as text and voice input, as well as the form factors, influence users' analytical workflows. We base our research on 3 questions. What are the characteristics of utterances asked through text and voice? What would users expect as a reasonable response? And lastly, what are the modalities for repair during a conversation? To help ground the possible design space of conversational interfaces, we employ Grice's cooperative principles that explore how speakers can be mutually effective during communication. These principles are divided into 4 maxims. Maxim of quantity states that a conversation needs to be informative and provide information necessary to understand the intent. Maxim of quality states that a conversation needs to be truthful. Maxim of relation states that the conversation needs to be relevant and only include information that is needed for the particular conversation. Maxim of manner states that the conversation needs to be clear and concise, avoiding any ambiguous language that would likely cause confusion. Based on these maxims, we identify a set of conversational design patterns. DP1, greeting and orientation that convey the purpose of the chatbot. DP2, conversations need to be a back-and-forth exchange without dead-end responses. DP3, acknowledgements and confirmations are important as feedback to indicate that the user's input was received. DP4, to minimize cognitive effort and redundancy, chatbot responses should be to the point and relevant to the user's intent. We also considered 2 additional design patterns that are specific to analytical conversation about data. DP5, when chatbots encounter an ambiguous or underspecified utterance, they need to provide feedback as to how the utterance was interpreted. DP6, finally, chatbots should provide interface affordances, whether it's through language or the GUI, so that users can refine the chatbot's choices and interpretations when handling ambiguity. To better understand user expectations, we first conducted 3 exploratory Wizard of Oz studies with these design patterns in mind. The first one used text interaction on Slack. The second study used voice interaction via a Bluetooth speaker. And the third study used voice with text interaction on an iPad. Here is an example set of the third study. Now, let's look at some sample interactions from the studies.
How many passengers are there?
Hold on. Let me find your answer. 1,309 passengers were on the Titanic.
What is the youngest person on the Titanic?
Youngest person on Titanic was 0.17 years old.
I mean, of course, it's on here, but it doesn't make sense. It's not natural. What would make it more natural? I don't know. The youngest person is an infant or something.
Percentage of passengers in cabin class 1 survived.
Sure. Getting back to you on this.
So what do you expect it to do here?
I expect it to probably give me a breakdown of
61.92.
that. I mean, not breakdown, that's exactly what I thought. It's pretty cool. Yeah. Okay. Because I asked a specific question, right? So there's no whiz there. Give me a breakdown of the percentage survived by class.
Here's your percent survived broken by class.
Okay, let's try something else. What was the average fare paid by the passengers? That's great.
$33.30.
The findings showed that voice modalities elicited a higher proportion of fact-finding questions. On Slack, people asked a variety of analytical questions. In general, there was a small set of follow-up utterances across all 3 studies, with the voice-only one having the least follow-ups. Based on our observations from these Wizard of Oz studies, we implemented a chatbot system to test users with actual working prototypes. All the chatbot systems employ a Node.js client-server architecture. The chatbot client listens to user events from the server and updates the UI or plays the audio responses. The chatbot server is the bridge between the client and the various components of the system. The parser parses the text and verbal responses and passes the parse tokens to the server to generate a system response. The visualization module generates visualization results to display in chatbots with a screen. Lastly, the natural language generation module generates text or verbal responses based on templates. We then conducted a second study to test how users interact with working chatbots. The Slack chatbot shows widgets and supports conversation threads. The Echo Show takes verbal commands and displays charts with text along with audio responses. And the Echo chatbot is completely voice-based. Here are a couple of sample interactions with these chatbots. Show me the wines by location.
The most expensive wineries are located in the United States.
Show me the most expensive varieties.
The most expensive variety is the Cabernet Sauvignon.
We summarize people's reactions to the 3 prototypes and highlight some of the key takeaways here. In general, we found that chatbots showing charts with natural language responses elicit richer analytical inquiry. We also found that fact-finding questions were most common in voice-based chatbots, and the responses tend to be short and succinct enough for someone to listen to. Threading and interactive widgets in Slack naturally supported multi-turn conversation. Both GUI and verbal affordances for repair in the chatbot interfaces kept people in the flow of analysis. To conclude, observations from the studies provide a better understanding of the principles for designing analytical chatbots, which aspects of the Gricean Maxims hold, and where new insights are identified. We hope that others find value in our work and explore new research directions and opportunities in developing useful analytical chatbot experiences.